Hello guys, this is Siddhanth Jain from the Anand Sagar College of Engineering, Bangalore. Firstly, I would like to thank Emergency for providing such opportunity for me being a part of this internship. In this internship, I was allowed to learn various technologies and also the hands-on experience with the applications. I would also like to thank our project guide Jayalakshmi ma'am for guiding us through this project. So let's get forward. Contents learned during the internship. The internship was divided into 4 weeks, where we were taught many things about IoT applications and also C programming, embedded system, microcontrollers, and also the Arduino IDEs. We were also working with the Pixim Lab simulator, which is nothing but an emulator which simulates the hardware's output. So week 1. In the week 1, we were taught all the basic concepts of C programming, which was required to code in the Arduino IDE. Not just for the basic concepts, we were even touched upon various difficult topics in C programming. C programming is very important language as it is a middle level language and also a high level language which has a rely on libraries, highly reliable on libraries, and which requires more memory, which is a major challenge in embedded system. C programming is also used to majorly used to communicate with the hardware. Topics learnt in C during the internship. We were taught of different types of data types available in C, such as int, float, double, and string. Preprocessors. There were different preprocessor directives that are included in the C programming. We were taught few of the preprocessing directives. Conditionals and loops. Conditionals and loops. Conditional statements and looping statements were even taught in this internship. Operators, arrays and pointers, strings, functions, essentials of C++ and classes and object, constructor and destructor, pages. Programming examples for each topics were also taught during this internship. Week 2. Project requirement and design for the Arduino programming. We know Arduino Uno is a hardware which requires an Arduino board. But during this internship, we were given Pixim Lab, which was an online simulator software where we could simulate the hardware Arduino using the Pixim Lab. Here, so here is the Pixim Lab. The Pixim, as you can see, Pixim Lab. It has many. It is an emulator of a development board integrated with MPX Lab. It is also used for Arduino IDE boards, and other microcontrollers are also supported in Pixim Lab. Pixim Lab basically allows us to simulate the hardware output. Pixim Lab also contains the oscilloscope where we can see the signal waveform output of the hardware as well. Arduino IDE. During this internship, a major software that we used and is the integral part of the project is an Arduino IDE. Arduino IDE is an integrated development environment which allows us to write the C programming in the C programming and also allow us to upload the programs to communicate with the Arduino hardware. The image below can show you the Arduino IDE sample. The, the tick mark in the Arduino IDE suggests that we can upload and verify. The arrow mark indicates the uploading direction to the hardware. So the project requirement of this internship was an LDR light dependent resistor. So an LDR sensor is a photoresistor which changes the amount of light falling into it. LDR sensor is connected to an light. The light sensor are connected to an LDR via ADC, which is analog to digital converter. The analog to digital converter converts the analog input by an LDR into its equivalent digital form, which converts later by certain formula for 0 to 255 upper bound. Based on that, we glow the LED. The other requirement of the IoT based project was the temperature sensor. The temperature sensor used is LM35 sensor, which reads the analogous value. The value is converted into binary and then later converted into temperature is calculated by obtaining values of the voltages. The sensor doesn't require any external calibration to provide accuracy in the result. This sensor is also available in PiximLab, which is used in the project. In the internship, we were also taught what is the application and also advantages of the IoT in modern day time. IoT is everywhere today. IoT is in many various applications, which we'll be seeing further. IoT and embedded system are integral part and cannot be separated. As I said earlier, Internet of Things has various of application in healthcare sector, wearable health monitors. The Fitbit today is also an example for wearable health monitor. Automobiles, Internet of Things is also available in automobiles. This has smart cars. Logistics and transportation, smart buildings. So as I told again, IoT is enormous and used in various applications. It is also used in transport and smart building, business, home automation, and everything. Embedded system. An embedded system is a combination of computer hardware and software design for a specific function. Embedded system may also function with a larger system. The system can be programmable or have a fixed functionality. So here the picture of an embedded system will also give you a brief idea of various application of IoTs. So a motion sensor sensing the car's vehicle speed, medical devices which allows in the healthcare, telecommunication, gaming, domestic applications such as IoT, and also the smart building that are built using modern hardwares. So, so during this internship, we were also taught of various microcontrollers and and the components used in it. Microcontrollers always contain a RAM or a ROM, and also PWM, which is pulse width modulation. We were also taught of a timer and a timers and counters, which are also an integral part of an microcontroller. ADC block and DAC block. ADC block, analog to digital converter blocks, and digital to analog converter blocks. Any communication today, we need any sensor which sense value always senses in analog. We require various sensors in this project, and we also required analog to digital converters in microcontrollers so that we could read the analogous value and to produce the digital output for the required analogous value. So in the week 3 we were given the overview of the project that we were supposed to build, uh, and this project is an IoT based home automation using an Arduino Uno board in Pixim Lab simulator. To remotely control the device we use an app named Blink IoT. We automate the garden lights and the brightness will brighten according to the sunlight. Temperature control system is automated. We have also integrated a temperature control system in this project. Water tank is automated by controlling inlet and outlet valves respectively. Project's objective to the project objective is to connect all and discuss the home application of the Arduino and integrate it with the Blink IoT app and also cloud. Obtain critical notification regarding temperature and water tank on the Blink app. Checking the real-time status of the temperature and the water level on the Blink IoT app. To control garden lights automatically. This were the objective of the project that we were given in this internship. So yeah, garden light control system. The property of an LDR sensor are applied to accomplish the controlling of the garden lights. During the day, the outdoor lights is maximum. So the LDR sensor detects the light and the garden lights is turned off. Whereas at the night, the outdoor light is very low. So the LDR sensor detects the light and the lights are turned on. So here we can see the block diagram of the garden light control system. An Arduino Uno interfaced with the LDR sensor, and Arduino Uno sends the values from the LDR sensor, which sends the values from the outer lights and gives the value for the Arduino Uno. Arduino Uno converts the analogous value read from the LDR sensor into digital and increases the light of the lights by sending the signal of these lights are basically an LEDs which are connected to an Arduino Uno. Need for home automation. If we focus on our daily lives schedule, there are many devices which we are not monitoring as we are moving to office, colleges and other places. Thus, to avoid such negligencies and also to protect our house from any accident, we can use this automation. We can control many home devices using automation. Few of them are covered in this project. You can see this home which is interfaced with our hardware and the Ethernet which we are going to be using. This Ethernet is allowing us to communicate with the Blink app and will allow us to send the information in the Blink app. This Blink app also has a cloud which interfaces with the Arduino Uno through the internet and sends the information to the mobile app in the Blink. This is the basic overview of the project. And then coming to the temperature control system. The analogous value of the temperature is obtained from temperature sensor LM35 and displayed on CLCD. After converting it into digital value using ADC, which is analog to digital, the controller of the temperature of the system by turning on and off the heater and the cooler through the Blink IoT app. The feature of this system is that as the temperature sensor reaches 35 degrees Celsius, the heater turns off automatically to avoid more heating. The notification of the same is being displayed in the terminal of the Blink IoT app. So here is the block diagram where we can find the temperature control system's basic working. Uh, so this is the Blink IoT app, which will be interfaced with the Arduino Uno, and the Arduino Uno will be again interfaced with the temperature sensor and CLCD. CLCD is nothing but the liquid crystal display, which will be displaying the value in the hardware. So what does this system do? The temperature system will be continuously sending the temperature values to the Arduino Uno. The Arduino Uno in turn sends the information to Blink IoT app through the cloud and the Ethernet. Uh, when the temperature is dropping cold, the user can turn on the heater by clicking a push button or a switch, through which the heater control will be sent to the Arduino Uno. In turn, Arduino Uno will be turning on the heater control in the temperature system. If the temperature is rising too high, the above 35 degrees Celsius, the heater will be turned off automatically. Once the user needs to cool this temperature, the user presses the cooler button. The Arduino Uno in turn turns on the cooler button and sends the notification in any of the occurring events. Water inlet and outlet valve control. In this system, the Arduino Uno is controls the volume of the water in the tank by controlling the inlet and the outlet valve by sending commands through serial communication, and displays the volume of water in the tank on the CLCD and also on the Blink IoT app. So this is the block diagram of the water inlet and outlet valve control system. So Blink IoT app interfaces with the Arduino Uno, and CLCD is directly connected with Arduino Uno, and water tank is also connected to the Arduino Uno. There will be a constant reading of the water in the tank sending to the Arduino Uno, and Blink IoT app will also get the information through the Arduino Uno. Whenever the inlet valve reaches the maximum of 3000, the outlet valve will be the inlet valve will be turned off, and the notifications will be sent through the Blink cloud to the mobile app of the Blink. So summary of the internship. uh, Using the Blink application and the Pixem Lab simulator, we simulate the home automation and where LED temperature system, serial tank resembling a light heat cooler and water tank in real time. CLCD acts like a dashboard using for displaying the events. Widgets from the Blink IoT app like buttons widgets are used to control the heater cooler and the inlet valve and the outlet valve. Gauge widget displays the temperature and the volume of the water. Hence, the project provides the perfect solution for home automation. Thank you. This is Siddhanth Jain. Now let us see the hardware simulation of the project. Before that, we'll be checking out our project code. So this is the home automation projects. It has been divided into several different uh, header files so that it will be easy for us to call every function in this C program. This is an Arduino Uno IDE where we can write a C program to interface with the hardware. So here we define the blink template ID and uh, the template name and token, which will be automatically generated in the Blink IoT app. The Blink IoT app looks like this. So here will be the device. This is the Blink app where we can create widgets and everything. So these are the protocols or the header files, sorry, uh, that we are calling to run our project. This crystal is used for the CLCD display. The temperature sensor is also an header file which has been written over here. So let us go to the code. Here we have declared some variables like boolean for the heater switch, cooler switch, inlet switch and outlet switch. And this is the unsigned integer. uh, Here we have written a function for cooler pin. The cooler pin takes the value. If the cooler pin turns on, the CLCD displays the value that cooler is on, else it will display cooler is off. If the heater pin is turned on, the function the if function defines the heater pin is on, else it will display off. Similar to heater and cooler, inlet and outlet valve are defined here. Coming back to the temperature reading, this sends the real-time value to the Arduino Uno and Blink IoT app. Uh, then the void handle is also a function which handles the difference reading of the heater values. Other main function is a void handle tank, which allows us to see the volume of water present in the serial tank. Void setup is a main function in the Arduino Uno's hardware, as we need to set up certain things in the Arduino Uno, such as the printing of t value, and then void loop. Blink app certain rules, and then comes this CLCD. We have declared a function CPP where we call the brightness of the light control system. Here also the LDR sensor values are being read. We are declaring all the virtual pins for the usage of the hardware, and another CPP program for serial tank for enabling the inlet and outlet valve, and also an header file to enable the serial tank. So let's get to the project output. Sorry. So yeah, this is the Pixim lab, and we'll be taking a serial port. So yeah, wait a second, I'm getting certain errors. Yeah, we can see the filling of the tank as the inlet valve is on. I'll go to the Blink IoT app. We can see messages that were there. I'll be turning off the heater for now. You can see as soon as I tapped off in the heater off messages there in the CLCD, and it will also be displayed in the notification tab. We can also take the real-time value of the inlet valve. So now I'll be turning on the turning on the heater, and you can see as soon as I push the button here, the heat of the temperature has started to rise, and the value is also being updated in the Gaussian widget in the temperature. Let us see after the 35 degrees Celsius, it should automatically turn off the heater. Let us wait for a few seconds, and also the notifications will be pushed due to some lag. There's no display, I guess. I'm sorry for the weak Wi-Fi. Yes, now we can see the notifications of the previous commands that I gave. See, as the temperature is, we can read here, the temperature is about 35 degrees Celsius. The temperature is about 35 degrees Celsius, so the turning on the off the heater. So I'll be turning on the cooler to check whether it works. Yes, it's working. Temperature is dropping below. Yeah, we can see cereal tank which is filled, and this is the garden light system which turns on and off according to the brightness. Yeah, we can also see cooler which is allowing. Wait a second, just waiting for the message to be popped up in the notification tab. We can see turning on the heater and the continuous changing value of the temperature. I guess there is a bit of a lag in sending notification. I've turned on the cooler. This also is a gauge for sensing the water, and as we can see, the water level is full, so the tank shows full. In this widget we can also type here. I guess there is a bit of a lag. Yeah, thank you.